Okay guys, this video is just going to teach us a little bit about understanding volume. So to start off with, remember when we're talking about volume, we're talking about three dimensions. When you're finding the volume of an object, you're specifically working with three-dimensional objects with volume as opposed to one or two-dimensional objects like with perimeter and area. Three-dimensional objects have a length, a width, and a height, and you can see that here. They have to have all three of those traits to be considered three-dimensional. So three-dimensional objects are never flat. Think about a 3D movie. When you attend a 3D movie, the pictures appear to become solid and they're no longer flat against the screen, but they look like they're coming out towards you. That's 3D, three dimensions. When we find the volume of the object, we must label the measurement. So once you actually go through the calculations and you find the volume of an object, you always need to label your answer. We label volume in something called cubic units. A cube, if you think about a cube like this Rubik's Cube here, cube shaped, it has all three dimensions. It has a length and a width and a height. Okay, so a cube is three-dimensional, so we measure volume in units that are three-dimensional. The way we show that, so for instance with this cube, its volume's 27, and then to label it I would put inches, assuming that each of these was actually an inch, and then I put this little 3 here. That means that I'm talking about three different dimensions. When we see that little 3, we actually say the word cubed. So I would say that this Rubik's Cube here has a volume of 27 inches cubed. Cubed meaning to the third power or three dimensions. Okay, so let's actually talk about how to find volume. Volume is a measurement of the capacity of a 3D object. So what does that mean? For an object with an inside, like a box, you're just discovering how much space is inside that box. And you can do this with either multiplication or counting. So counting. To find the volume of this box by counting, what I would do is I would take a bunch of cubes and fill the box up, counting them as I go. And this is something we actually usually do in class when we're there. The cubes would all need to be the same size, like 1 inch by 1 inch by 1 inch, or 1 centimeter by 1 centimeter by 1 centimeter. They all have to be the same size. And you would just start placing the cubes in here. You'd have a whole bottom layer of cubes, and then you'd start stacking them on top of each other. Now this strategy works really well for most three-dimensional objects, but there's a few things that would kind of get in the way. This strategy might not work so well if you had a container that does not have straight edges. Or if you had something really large, like a swimming pool, if you wanted to find the volume of a swimming pool, it might take a really long time to fill it up with cubes, so that might not be your very best option. Okay, so other than counting, I can also find volume by simply measuring the length, width, and height of the object and then multiplying those numbers. So for example, here I have this box, and because it's a box or a cube, all the dimensions are going to be the same. The length is 2, the width is 2, the height is 2. So I wanted to show you actually how we would solve for this. So if I'm finding the volume of this, remember I have to take the length and then I multiply that with the width and I multiply that by the height. Now sometimes kids worry that they're going to do the numbers in the wrong order, like that they're not sure they have a hard time telling the difference between the length and the width of something. Remember, with multiplication, because of the commutative property of multiplication, we can multiply in any order. So it really doesn't matter if you do length, width, or height. You could do height, width, length. As long as you're multiplying all three numbers together, it will be fine. So for this example, I can see that my length is 2, my width is 2, and my height is 2. So I'm going to multiply all these together. And another thing we talk about in class sometimes is you really can't multiply 3 numbers all together at once. What you're really doing is you're multiplying these 2 numbers together, and then you'll multiply that last one. So I know 2 times 2 is 4. And then I'm going to multiply that by 2. That gives me 8. These are in feet. And remember, since this is a three-dimensional object, I'm going to put that little 3 there. So I have 8 feet cubed for the volume of this box. All right, so let's talk about the other way. So like we said on the last 2 slides, there's 2 ways that I can find the volume of a three-dimensional object. One is with counting and the other is multiplication, but there's also one other method, and we're going to talk about that. So what if you have a three-dimensional object, something that's not flat, but you can't fill it up? For instance, like your cat. Let's say you wanted to figure out the volume of your cat. It's obviously three-dimensional, but it's not really easy to measure the length, width, and height of a cat. So what would I do? So for an object that's solid, and you're trying to figure out how much place that object or space that object takes up, you can find this with water displacement. That's the way that you would find volume. So now we've got counting, multiplication, and water displacement. I would never suggest doing water displacement with your cat if you want to live. So we're going to talk about what that is. So you've actually seen water displacement in real life. Think about when you step into a bathtub, it's full of water. What happens to the water? You sit down in it and all of a sudden the water rises, right? So you've actually displaced or moved water. There's not really water under you. If you think about that when you're sitting in the bathtub, you can feel the bathtub underneath of you, right? So you've actually moved the water out of the way and you've taken its place instead. You've moved it. Now, when you get in the bathtub, you really don't know how much water you've moved because there's no measurements on the side of your bathtub. But there are tools that are out there where you can measure water displacement even for larger objects. Here's a little example they did with some graduated cylinders. So you can see we've got this and it's at 150, looks like we're in milliliters. It's 150 milliliters and they dropped this rock in, okay? And then after the rock drops in, just as you would expect, the water rises up a little bit. It's moving the water, just like the bathtub scenario. And now I can see these bigger lines are counting by tens, but I'm at 150, 160, 170, and 180. It's now at 180. So if I was at 150 milliliters and I'm now at 180 milliliters, well, how much water did I move? It looks like there's 30 milliliter difference, right? So I could say that the rock's volume is 30. I hope this helps you understand volume a little bit better. Typically in a classroom setting, we're not going to do as far as assessment and testing whether you understand volume concepts. We're not going to do a lot with water displacement, at least in the 5th grade. You're going to be more geared towards counting or multiplication. I hope this helps.